Okay, thanks for the introduction, Nick. I decided to talk about RedRock because it was a great experience for me. The fast pace was definitely a great experience. RedRock is an iPad application that we built in 10 days, and it can process, analyze, and visualize data, terabytes of data in just a few seconds. I was one of the data scientists participating in RedRock, and I was in charge of the machine learning algorithms. My outline is the following. I will start first defining what is RedRock. So it's not the national park that is close to Las Vegas. It's an iPad application. I will talk about the method that we use to grow up to work together in a team. That is called, we call it IBM Design Thinking. It's a series of activities that help us work faster. Then I will go through the details of the machine learning algorithms used. I will demo the application, and I will end up with a summary. Another thing that RedRock is not is a product. So we are not selling this. This is more an experiment. So we decided to do this experiment, and the setting of the experiment was what happened if we put together 2 data scientists, so I was one of them, 3 developers and 3 designers, and we employed the IBM Design Thinking, and we have 10 days to work on it. Can we come up with an easy-to-use app that can process, analyze, and visualize terabytes of data in seconds? That was the question, and the answer was yes, but of course we want to know what was the solution, right? What the quality of the solution of that experiment. So what RedRock does is we use Twitter data, and this is on the right here. I show the main screen of the app, and here you can look for a hashtag or a word or a Twitter handle, and it's powered by IBM Analytics, and it's running on Apache Spark. We use Decahose Twitter that is taking 10% sample of the total public tweets, and that's very important for the experiments. So first, design thinking is about exploring a bunch of possible solutions and then converging to one. It has 4 different steps. In the first, we understand the problem and we identify clearly who is going to be our final user. Then we explore several solutions. We pick one, we prototype that one, and then we evaluate. In the first 2 steps, that are understanding and exploring, so understand is a series of group activities. We come up together as a team, we sketch who's the final user, what the final user is thinking, what is the problem. So we collectively understand the problem clearly, and so in some cases, the developer goes with an idea and go do all the code. Maybe data scientists, okay, this is a very interesting problem, so I'm going to solve it. But then you come back with a solution, but it's a cool solution, but maybe not the solution to the problem that you needed to solve, right? So this is good to put all together, all the team members in the same page. Of course, collaborate and be creative. So after these group activities, you are very free to go talk to your designer or the developer, right? So after we understand collectively the problem and the user, we explore all the possible solutions. Here I show a picture where we are brainstorming in these big whiteboards that we have. And after exploring all our possible solutions, we pick the one that seems to be the best at that moment, and we prototype. That is the next step. In prototype, us, the data scientists, we go and do what we love. We do our math, we build models, we run experiments, test accuracy, all what we like. And the designers go and do digital sketches of not only each of the screens, of how things are going to look, but the whole flow. the whole experience as a user. And the developers, of course, are always in the middle, communicating actively with both sides. They're making sure that things are going to click later. And finally, we come together again as a team. We evaluate our prototype. And of course, we iterate back to explore. Can we make it better? How? We enlist all the ways that we can make it better, and we prioritize. Okay, this is the most important, and we only have a few hours or maybe until tomorrow to do it. So we iterate several times until we reach the 10 days in this case. So let me tell you a little bit about the architecture of the app. We have a 20-node cluster, a soft layer cluster, and we have installed Hadoop, Apache Hadoop and Apache Spark, and we have our Twitter data sitting in Hadoop. We're only using Hadoop as a distributed file system. So our analytical engine is Spark, and the app sends a REST API query to the soft layer. Spark does all the heavy lifting, and we get back a result in some seconds. And of course, all the machine learning happens in Spark. And the two machine learning algorithms that I use were word-to-Beck, that is based on deep learning. So it's been a very adequate algorithm for this conference. We have been hearing about deep learning all day. And K-means clustering. And I use Spark. Spark comes with 4 different packages. Spark SQL, Spark Streaming. We hear a little bit about streaming a while ago. MLlib, that's exactly the package that I use. I use the word-to-Beck and K-means that come with the ML library. And GraphX, that is for graph analytics. So word-to-Beck was proposed by Mikolos and all in 2013. And it's a tool for computing vector representations of words using deep neural nets. Word vectors, these vectors capture linguistic regularities of the words. So to give you an example, the vector associated with the word king plus the vector associated with the word woman minus the vector associated with the word man, hopefully is going to be close to the vector associated with the word queen. And I say hopefully because you need to make it work, and for this you need enough data and enough vector dimensionality and some other parameters that I will mention later. So going back to the RedRock problem, so we're giving a word. It can be a hashtag or a Twitter handle or just simply a word. What can we give to the user, right? So I'm not an expert on natural language processing, so I was starting to study natural language processing, but I have been studying vectors and vector spaces for years now. So when I started to read about word-to-Beck, I was thinking, this is perfect. This is going to put me exactly where I want to be, and I feel comfortable with vectors, so let's explore the tool. And after computing some experiments, I realized that it was the way to go. So I ended up, so this is my pipeline. I ended up using like about 6 terabytes of data of the Twitter decahost, that is like a month of data, which I then picked the tweets in English, of course. Then I did some parsing, and that's the data that I used to train my word-to-Beck matrix. The output of this model is a vector associated with each word in the dictionary. So we have a vector associated with design thinking, another vector associated with deep learning. This whole thing took 3 hours to run on a 10-node cluster. Now that we have a vector, a numerical vector associated with each word, we can measure similarity between words by measuring the angle. And usually the cosine distance is used, that is the dot product between the vectors divided by the norm of each of them. To give you an example, the similar words to design thinking are collaboration, inclusion, product management, and so on. And other example, similar words to deep learning are machine learning, ML, smart data, and so on. So what I learned about building this word-to-Beck matrix and doing all those experiments in a short period of time, this is something that I like to hear in some of the talks, because you will not going to read about them, and it's basically your experimentation and the intuition that you gain when you play around with the algorithm. You really need enough data. So when I was testing, of course, I did small data, but a week of data was not so accurate, and then 2 weeks, still not so accurate. Less than 20 days was starting to be very accurate, and 30 was so I test 35, and it was pretty much the same, so I stick with 30 days. Of course, the more the better, but the limitations are your cluster size and the time that you have and you want to spend in each experiment. So if you spend 3 hours in each experiment and you have only 10 days, then you're not going to finish, right? But 30 days was pretty good. And also the vector dimensionality that I forget to mention a while ago, that in line with the videos that we have been seeing, it's related with the number of hidden layers in the deep learning. And I use 100. So each vector associated with the words has 100 dimensions. And I tested that 100 was enough, because I compute singular value decomposition of the matrix. I plot the singular values, and I realized that 100 was already decaying enough, on the order to 10 to the minus 3. So 100 was a good value to choose there. But that may vary if you change to a different data source. Also, there's another very important parameter here that is called mean count. And that's the number of times that a word needs to appear in your data so that it's considered in the dictionary. And that's very tricky, because you want to have a small number here, because you want to be sensitive also to words that do not appear too much. And you also have the restriction of the 10% sample. So if you're looking to some words that appear not very frequently, then 5 is fine. If you are looking into something much more specific, maybe you will go for more in this parameter. So after building the word-to-Beck matrix, I got a 90K by 100 matrix. So from 6 terabytes of data, I have a model that you can put in your laptop. You can compute distance, cosine distances with all your words. So this is very easy to manage and to put in the iPad application. And on top of this matrix, so of course, each of the rows of the matrix is associated to each of the words in my dictionary. So I applied k-means clustering, and I got a label for each of my words. And these are the 2 machine learning algorithms that I used. So the pipeline, a simple pipeline, would be, I got the data from Twitter, I applied my filters, my cleaning, my parsing. I built the word-to-Beck matrix. That is going to be one of the screens in the iPad. And then I apply k-means. That is going to be another screen in the iPad. Okay, now is demo time. Okay, so here on the top right, that's the RedRock application. I'm opening it now, and I'm going to look for hashtag sports. Okay, so now we send the request to the 20-node cluster, and right now we have about 10 days of Twitter sitting in our Hadoop. So it's going through these 2 terabytes of data, and that is equivalent to 350 million tweets. And here on the left, I show some of the tweets that contain hashtag sports. And we order them with the number of followers on the top. So the more followers, the more you will see it here. So yeah, the first has 1.6 million followers. The second only 450K. So, and here on the top center, I show 3 numbers. It's the total number of tweets, that is 350. Then the total numbers of tweets that contain the hashtag sports, that is 22K. And 7K users tweeting about hashtag sports. And this screen shows word to Beck. So when I submit a hashtag sports, it goes and compute these cosine distances with all my words. I sort, and I get the top 20, and this is what I show here. So, for example, we're close to soccer, hashtag hockey, and Tom Brady, and so on. Then another of the screens shows the volume of tweets in time in the world. So you can see who's tweeting about hashtag sports or which countries. Then a breakdown of the users by profession is shown in this screen. So most of the people are from marketing. We also have this sentiment analysis of the 10 days. We notice here a very huge spike on August 20, where we have like 800 positive tweets. And so something happened there, right? So I'm not a sports fan, so but my wife's uncle is, so I call him and I ask him, hey, what happened? And he goes, oh, there was a baseball game, and this pitcher from the Astros, Mike Fiers, received no hits in the whole game versus the Dodgers. And that was what happened. I went and I checked the news, and it was what happened. So the next step, in the next generation, we wanted to somehow connect here with the thing that happened, right? And then the last screen that I will show is the K-means clustering. So we have a cluster about NFL, and we have some other little clusters here, hockey and LA Times, and that's it. That's what RedRock is. And let me summarize. So the RedRock experiment taught us that a team with a diverse background and following this series of experiments of design thinking can help enable an agile development environment. Also, so Word2Vec maps unstructured data into a vector space. And unstructured data have been studied for only some years now. Vector spaces, much more. I think the first person that called vectors was Newton, but please correct me if I'm wrong. I think it's 1700s in the context of physics. So I wonder if this idea can be generalized. And there was a talk about this morning. C. Jong. I wonder if you can do image to vector or video to vector or any binary file to vector. So I think that would be a great path of investigation. So finally, RedRock transforms a large amount of data into an easy-to-digest set of visualizations that are accessible to a general audience. I would like you to meet the team, and thank you for being here. And come to the booth if you want to check the app.